Okay. Welcome to our GIS Forum Online, and my name is Xu Yun, Product Engineer of Big Data and AI R&D Center. And today I'm going to give you some introduction about SuperMap Big Data GIS Technologies. So firstly, there are 5 key technologies of SuperMap GIS, BITCC, and we are going to talk about the B, Big Data GIS. SuperMap has been researched in Big Data GIS technologies since 2017, and we have implemented these technologies in our production of version 9D. So I think some of you, well, most of you may not be strange to spatial big data. It comes from many different sources like POI data, traditional surveying and mapping, or modern mobile internet. And there is one special kind in spatial big data that is real-time car GPS or personal mobile GPS. This kind of data is dynamic and it will change with time. And we can also call it streaming data. And there are 4 V of big data, and big data features that are large volume, rich variety, low value density, and fast velocity. And for spatial big data, there is one more L, that is with location. So to make use of this spatial big data, we have this Big Data GIS technology system. And the basement is the data storage techniques. And the core parts are data analysis and streaming data process. And above them is data visualization. And on the top is software development and the services for industrial applications. First is for spatial big data storage. Well, there are many distributed spatial data engine that have been developed, like Edgebase, SuperMap DSF, Elasticsearch, MongoDB, and the last one is some Circle Server database. And well, each of them has their own characteristics, and I'm going to introduce 2 of them in particular. First is Edgebase. Edgebase is a very good storage engine for data querying and data management. For example, updating or importing and deleting. This is a demo for 450 million features stored in Edgebase and displayed in SuperMap iServer. We can see that it is very fluent. So Edgebase could be your first choice if you have a very large amount of data to be displayed. And the second is Elasticsearch. Elasticsearch is a very good storage engine for dynamic data and also streaming data. Well, it has an advantage for an instant aggregating, like here, and is a grid map of 1 billion airplane locations. It can react very quickly. So if you have a large amount of streaming data, we recommend Elasticsearch. And then is spatial big data analysis. Apache Spark is a very popular distributed calculating frame, and SuperMap has supported many spatial big data algorithms with Spark calculating frame, like vector data analysis, raster data analysis, and machine learning algorithms. We have more than 60 in total, and all of these algorithms can be can be used in the distributed environment. And I'd like to introduce some very popular algorithms. First is cluster analysis. Suppose we have many text location data, like these gray spots on the screen, and we could use cluster analysis to find some hotspots of these places where people are likely to take in a taxi, like these color dots on the screen. And when we connect the results to the map, we could find where is the specific locations, and that are squares, malls, or hospitals that people are likely to take in a taxi. And this result could be a reference to urban planning work to find if the traffic planning is good or not. Next is OD analysis. OD analysis, O is for origin and D is for destination. Well, this is OD analysis for cell phone signals in the morning and in the evening peak. And we could find two places that are very special. The first is Tiantongyuan, which is a residential area in the suburb of Beijing. And we could find that people are likely to leave in the morning peak and go back to this place in the evening peak. And the second is Guomao, which is the CBD of Beijing. And the situation here is in the reverse of the first one. So use OD analysis, we could find the people transferring condition in between different districts. And this could also be applied in some fields of like public health. For example, for recent popular topic, coronavirus, we could use OD analysis to find if there is a relationship between people transfer and the outbreak of the disease. And the last one is zonal statistic. And this is a classic spatial analysis algorithms. I think maybe most of you have used it, but for large amount of data. For example, here we have well, more than 10,000 Bayesian polygons in North America, and we have 60 years of teeth data of annual participations. There are about more than 300 gigabits. And we could use the distributed algorithms to calculate all of this data at one time. So we could only spend about 4 hours to finish this calculation. And then for streaming data, SuperMap use Spark streaming calculating frame for the streaming data process. This frame includes, well, importing, calculating, and exporting parts. And for calculating parts, there are four key algorithms that for attributes, there are filter and map. And for spatial, there are also filter and map. And this is based on the geographical fence, which is an area defined in advance and that we are interested in. We could use spatial filter to find if the spots are inside or outside of the geographical fence. And use spatial map, we could not only find the location, but also the status of the spots. Like here, from T0 to T4, we could find this, for this point, it entered the geographical fence in time T2 and leave it in time T4. And this is an example for geographical filter of some airplane streaming data. and we could easily find which plane is in the above the large cities at each time. So this could also be used in the children's cell phone manufacturing company. For example, if parents don't want their children to live far away from their home or their school, they can define some geographical fence around the school area or home area. And if the children leave this area, parents could give a notice, receive a noticement. And for spatial big data visualization, well, normally we get big data like this, and there are points everywhere, and we could hardly find any valuable information in this map. So, but if we use aggregating algorithms like reconstruction tracks, well, we could easily find some patterns between countries or each cities in this map. And furthermore, if we extract long tracks in the results, we could get a much clearer map. So literally speaking, we could use aggregating algorithms to help us get a more readable map for data visualization. And for statistical spatial data visualization, there are heat map, hexagon grid map, rectangular or polygon grid map. And for streaming data visualization, there are cluster data analysis, density analysis, track reconstruction, like I just mentioned, and OD analysis. And this is also an example of simulation 3D model with a real-time traffic density analysis. And the analysis result is on the right bottom of the screen with some green and red lines in the map. And we could easily find the traffic condition in the density analysis result, where red road means crowded and green means that it's not crowded. And this is another example for the coronavirus disease. This is a dynamic polygon map of the disease in each country in the world. And we could get a streaming map for the cumulative number of confirmed cases from about February to recent date. And this could be reached in the website on the screen. If you're interested, you can reach the linkage and find the data. So for these whole big data GIS technologies, SuperMap also provides some products for each part. Like firstly, for storage and analysis and streaming data process, we could use iObject and get some big data API for the second development, and also use iDesktop X, and we could get some toolbox in this desktop client product. And for iServer, it provides some distributed analysis service and the streaming data process service. For example, here, this is a demo of using iDesktop X to connect to an edge-based database. And we could easily import data from UDB dataset using iDesktop X and import it to the edge-based data storage. And we could browse the attributes or the attribute table on the iDesktop X. And we could easily make a template, make a thematic map And we could also publish it. We could publish the map result to the website, to the map service of iServer. And after the publishment, we could explore the result on the website. So, and next, for data visualization, SuperMap also provides multiple terminal products for your big data visualization, like in the website or desktop client or mobile client. And we also provide some ready-to-use web apps, which is very easy to be acquired, and you could reach it just in your browser, and you don't need to know any distributed knowledge. Well, the first is Data GIS, which you could use it to make some thematic maps for static or streaming data. And you could reach it by the linkage on the screen. And the second is Data Insights. Data Insights is a product that gives you some management to generate some reports that containing maps and charts and text on the screen. And the last is Map Dashboard. Map Dashboard is a place that you can combine the map and the statistical results on the large screens. And here we also give you some templates for Map Dashboard, and it's very good for data monitoring. And the result could be also adapted to many different terminals like PC or pad or mobile. And the last one is software development and industrial applications. And this part, my colleague Bill Lee will give you more specific introduction about this part. And let's looking forward to it. So that's all I want to share today. Thank you for listening.